There are two modes in computer graphics, the immediate mode and the retained mode. The two modes are basically rendering strategies. In either case, objects are specified by vertices, which are locations in space, 2 or 3-dimensional. Geometric entities are formed such as points, lines, circles, polygons, curves, etc. Older versions of OpenGL API adopted a rendering strategy that was known as immediate mode graphics. In immediate mode graphics, as the name suggests, each time a vertex was specified in an application, its location was sent immediately to the GPU. This is an old style programming, and it used the GL vertex command for doing so. Immediate mode graphics has its advantages. There is no memory required to store the geometric data at the GPU. However, there are many more disadvantages. As the vertices are not stored, if they need to be displayed again, the entire vertex creation and display process must be repeated. This creates a bottleneck between the CPU and GPU. Immediate mode graphics has been removed from OpenGL 3.1 onwards. In retained mode graphics, we put all vertex and attribute data into an array, and we send the array to the GPU to be rendered immediately. Retained mode graphics overcomes the vertex creation problem. However, we would have to send the array over to GPU each time we need another render of the scene. A better solution is to send the array over and store it on the GPU for multiple renderings. This is why we need more memory at the GPU. Retained mode graphics is adopted in OpenGL 3.1 onwards. Let's look at a side-by-side comparison of the two modes in pseudocode. Here we have the immediate mode graphics, and here we have the retained mode graphics. We define the main function. After initializing the system, we find the initial point of the Sierpinski's triangle. This is given in your book. The definition of the Sierpinski triangle is also given in your book. It's basically a recursive program to make a nice looking set of triangles. Here we have a loop that runs for a certain number of points. This loop also runs for a certain number of points, but here every time a point is generated, it is displayed. But here every time a point is generated, it is stored and not displayed. And once the loop is complete, once all points have been created, they are displayed once, whereas here the point is displayed as soon as it is created. Hence, this requires less communication between the CPU and GPU and results in efficient rendering.